Introduce our next presenter, Sachit Balamurugan, on the deep learning on MRI and transcriptomics for ACC GRB10 biomarker discovery and multi-cancer prediction.
Good morning, everyone. My name is Sachit Balamurugan. I'm from Little Texas, USA, and I go to Texas Online Preparatory School. My project, deep learning on MRI and transcriptomics for ACC GRB10 biomarker discovery and multi-prediction model. Adrenalcortical carcinoma is a very rare and aggressive cancer in the adrenal glands. It has a national incidence rate of 0.7 to 2 individuals per year. Because of its rarity, it often goes undiagnosed until its later stages, where it's much more deadly. ACC can also spread to the livers, lungs, and kidneys, and form secondary tumors like HCC and lung cancer, and shares genetic overlaps with other types of cancers as well, like pheochromocytomas, pituitary tumors, of a radiologist, predicting ACC, showing the potential AI has in solving these types of issues. I discovered two biomarkers from this study. Some of the current biomarkers right now are IGF2, TP53, CTNNB1, as well as hub genes like ARCA and T1MS. So let me go into the introduction. So through the study, I'm trying to do two goals: enhance diagnostic accuracy of MRI images and predict 7 types of cancers, including ACC, HCC, lung cancer, neuroblastoma, pheochromocytoma, pituitary tumors, and RCC. As well as my second goal is to predict adrenalcortical carcinoma through genetic data as well and discover new biomarkers through it. And I'm going to do this through CNN architectures such as BGD16, ResNet50, MobileNet V2, and conventional next timing, and my own custom hyperparameter CNN model. My data methodology. I publicly sourced all the data from PubMed, Radiomedia, and the National Cancer Imaging Archive, as well as other sources, so I don't waste resources and time, and then it outputs out the best hyperparameters, and it gives out the results. So this is the results I got for ACC only AI model. MobileNet performed the best out of all my other types of models. It had a training accuracy of 97%, testing accuracy of 92%, and a validation accuracy of 90%. So all my models actually performed much better than most researchers research for this type of cancer out there. Although my custom model didn't perform as great as my other pre-trained models, it still had a relatively high accuracy compared to other research. And all my models throughout had very high precision and recall, as well as low loss. This is the multi-cancer AI model results. So BGC16 actually performed the best in this case compared to MobileNet V2. MobileNet V2 was very close to it. BGC16 had a training accuracy of 99%, test accuracy of 95%, and a validation accuracy of 88%. And my custom model actually did really well, but it suffered from overfitting. That's why it had a 73% validation accuracy. And this is the results for AUC, ROC data for adrenalcortical carcinoma AI model. So as you can see, I had very high true positives and true negatives, as well as low false positives and false negatives, and very high ROC values all over 0.93. This means that my model is correctly classifying cancerous images as cancerous and non-cancerous images as non-cancerous. And then for the multi-cancer results, I also have very high true positives and true negatives, and low false positives and false negatives, as well as a very high ROC curve here as well. And now moving on to my AOC, ROC data and results for my ACC transcript and genetic profiling data. My custom model actually performed better than my pre-trained model in this case, with an 82% accuracy and an ROC of 0.92 and very high true positives and true negatives. In this case, the false positives were relatively high, but it's still, compared to the amount of data I have here, it's still low. Then over here is the top biomarkers that the model has outputted. So TP53, CTNNB1, and GRB10 are the top 3 biomarkers that are most used for classification in my model. And GRB10 and BCL2L1 are 2 new biomarkers that have never been discovered before. So these are biomarkers that I have discovered through my study. And the image to your right is the exact regions my AI model is predicting the cancer. and it's correctly predicting it in the cancerous areas and finding the correct tumors. So all of the images over there are correctly finding the 7 cancers. So in conclusion, through my study, I discovered 2 new biomarkers, GRB10 and BCL2L1, as well as validated the other types of biomarkers like TP53 and CTNNB1, as well as created multiple models with high accuracy on predicting ACC and 6 secondary tumors. Thank you.
Does anyone have any questions?
You did an amazing job. This was an amazing presentation, and you should be so proud of yourself. I had a question about your biomarkers that you identified. How was the process of you finding them? Did you input the images of the, I think you said you got cancer MRI scans, I think, from a database. Did you use that to find the biomarkers, or how did you go about that?
Thank you so much for your question. That's actually a really good question. So basically, the MRI images are separate. In this case, I used genetic profiling data, specifically transcriptome profiling, and I got it from the TCGA ACC database. And basically what it did was, it's basically just genes, and I basically go through all of these genes from the 10 sources I got, and find the top 500 variable genes. So these are the genes that alter between normal and cancers, and through this I'm using that data to discover these biomarkers basically. Thank you very much.
Okay, thank you.
We have time for another questions.
What software environment or programming language did you use for the
Okay, so thank you for your question. First of all, for all my AI models, I use Python, but specifically for this transcriptome profiling data, I had to use R to directly get into the database of TCGA, and then I use Python for the actual machine learning part. But for just data pre-processing, I use R. Thank you so much.
Thank you.
Thank you so much for your presentation. So up next we have